So now let's talk about trying to figure out what the angle is in a right triangle if you don't know either one, but you know some side lengths. Now the way we're going to start off approaching this is similar to how we were finding missing side lengths. We're going to identify what we're trying to find, what we have, and writing a trigonometric equation related to that. So for instance, in this one, we're trying to find angle A. We happen to know these two sides, which are the opposite and the adjacent, which means we could use tangent here. We could say the tangent of A equals opposite over adjacent. So in terms of this problem here, my opposite is 56, my adjacent is 42. That does simplify, but who cares? Because we're going to be putting the calculator anyhow. So I'm going to actually write this 56 over 42 a little bit off to the side, though. And the reason for that is my goal now is to solve for A, to get the A by itself. I have to undo tangent. Now, tangent by itself isn't a number. So one of the tempting things that I've seen people try to do before, which is not legal, is to try to divide by tan. We can't do that because tan isn't a number, tan is a function. That would be similar to if you had square root x to try to divide by square root. You can't just divide by square root. It doesn't work that way. We normally can only divide by a number because it's multiplication, and how you undo multiplication is with division. This doesn't say tan times A, it's tangent of A. A better way to write this is even to say tangent of A. We're plugging A into the tangent function. The way that we can undo the tangent function is with what we call the inverse tangent or the arctan. So we can take the inverse tan of both sides, that inverse tan kills the tan, and leaves us with just the A. And now this is something we can put in the calculator. We can use the second and then tangent button, and then we can put in the 56 over 42. And now this gives us an angle in degrees, because that's what our mode of the calculator is set in. So it's looking like about 53.1 degrees. Now we could do similar by looking at B and saying the tangent is 42 over 56 and use the calculator for that. But even easier is to realize that angles A and B are complements of each other. And so they're going to add up to 90 degrees. And so we could just say, hey, what's 90 minus this answer? And you can do second and then the negative sign to put the answer in your calculator. That's the answer to the previous problem. And we see that it's 36.9 degrees. Now we can check our answers here, sort of. That we could say, hey, angle A here, I know its tangent is supposed to be 56 over 42. So I can say, hey, what is 56 over 42? It's 4/3, or about 1.33. And then I could go to the calculator and say, hey, what's the tangent of 53.1? Now we might not get exactly 1.33333 because of the fact that 53.1 was rounded. But if I hit enter, it's pretty darn close. So this tells me, yeah, I did a pretty good job. It looks like this is a pretty good approximation. Let's look at the next example. So in this case, we are also given the two legs. If we use the Pythagorean theorem, we could quickly determine that the hypotenuse is 15. And I want to do that in this case just so I can kind of show you using other trig functions. So if we're trying to find angle A, we could say, all right, here's angle A. Well, what do I know? I actually know everything. So I can use any trig function I want here. This 12 here is the opposite. The 9 is the adjacent. And the 15 is the hypotenuse. So let's go ahead and use cosine just to do something a little bit different. We can say the cosine of A is adjacent over hypotenuse. So in terms of this problem, cosine of A is 9 over 15. Now again, to undo cosine, we need to take the inverse function. So we're going to take the inverse cosine of both sides. On the left, the inverse cosine and the cosine undo one another, leaving just the a. And then we get inverse cosine of 9/15, which we're going to put in the calculator. So in the calculator, we do the inverse cosine of 9/15. And we actually get 53.1, again, interesting. Which means that the other one, we can just take the complement of to get 36.9.